Hello there. This is Douglas Rumbaugh. Now, I thought I'd try something a little bit new and interesting here. And I want to try tackling some live programming. Well, it's not really live, I'm pre-recording it. If there's interest though, I might be convinced to live stream some of this. It could be fun. I've often thought about that. But in any case, basic idea of what I want to do here is I want to take a programming problem. In this case, I have the problem written right here in this window. A problem which I have not solved or thought about in quite some time. And just try and approach it with zero preparation. I have a problem, I have a couple terminal windows, and see about walking through my process for solving this thing in front of, well, again, this is pre-recorded, but theoretically in front of an audience. And just kind of to demonstrate, problem solving and show you how I tackle these. Now, I do want to point out that what I'm doing here is I'm going to be doing pretty much the very rough first pass solution to these problems, and I'm going to be restricting myself for the most part to fairly conventional programming structures, which means that in this particular video, for example, I'm going to be using Python just because I felt like writing some Python code tonight. But I'm going to be steering away from a lot of very Python specific conventions just to keep everything generally applicable, right? At the end of the day, programming consists of a couple of very simple concepts and then a whole load of syntactic sugar dumped on top of it. And so I'm just going to stick to the fairly conventional approach, which means that my code is probably going to be awful Python code, judged in the context of Python code. And it also probably won't be the most efficient thing in the world because this is just a first pass, so know what you're getting here. In any case, the problem which I'd like to attempt to solve in this first iteration is a very classical and conventional programming problem. It's the sort that you'll probably encounter very early on in any programming class that you take, or even if you don't, it's of that same sort. And the problem is to write a program which accepts Roman numerals on standard input, converts them to decimal integers, and displays them, writes them to standard output, that is. So the basic rules for Roman numerals are as follows, and then there's also this subtraction rule going on that we'll address then. So the basic idea, I'm assuming you're probably familiar with Roman numerals, but if you're not, your basic idea here is that the numeral consists of a sequence of these letters. Each letter has a numerical value, and you add them up. So for example, if I wanted the number 8, 8 is VII, because the V is 5, and then each I is worth 1, so 5 plus 1 plus 1 plus 1 is 8. And so I think, just think about it that way, the beginnings of a potential solution seem to become very clear, right? We're going to read in the Roman numeral, which is going to be a string. Roman numerals can't have spaces, so we'll end up probably using spaces as our delimiter. This program's going to want to accept Roman numerals, so I'm going to want to set this thing up so that I can pass in a bunch of space or white space separated numbers, have it translate each one. Well, I'm not going to worry about that yet. Let's get the basic algorithm going, and then we can worry about the input. So actually, on that point, and this is a new setup. I'm trying out Pop! OS. I really need to reconfigure my prompt so as not to have my entire path that gets a little bit asinine. Anyway, what was I saying? Right, I'm going to want to create my file. Let's just call it rn converter. rn converter for Roman numeral converter. And let's see. Well, we're going to be using standard in and standard out, so I'm going to want sys at some point. That's where those things reside. And let's see, there's a mapping involved, so we're probably going to want a dictionary for that. All right, here's what we'll do. So I'm going to make a go ahead and throw an execution guard in there, and then let's just for the moment ignore the IO component. I'll just accept a string as an input argument, just one of them, and then we can get the input processing dealt with later. So I'm going to say something like get strings from standard input, which is probably going to be a read line. Yeah, we'll do a read line and then split it on spaces. That's probably the simplest way to do that. And then just for temporary testing code, I'm going to say that my Roman string is sys.argv1. And I'm going to need to parse that string. Let's see. Matter of fact, let's just make that a function. Say parse Roman, which accepts a Roman as input, my Roman numeral string, and is going to return as output the integer representation. So the basic structure then of the program is going to be we get our string, and then we are going to parse that string. We'll call it decimal equals parse Roman string. And then we want to display it as output, so let's print it for the moment. I may switch that to assist.standardout.write. Probably isn't necessary to do. I should have filled that up before we started. Okay, so the question then becomes, we gotta deal with this parse Roman. So as a first pass, I'm going to implement this functionality and ignore this subtraction functionality here. It's not going to be too hard, I don't think, to account for this, but let's just get this working first, and then we can go and insert this into it later, rather than trying to do it all at once. Again, ordinarily I'd probably just do it all at once, but we'll pretend this problem is a little bit harder than it is. Huh? So we're going to, let's see, let's do an accumulator loop for this. So we'll say my accumulator is going to start at 0, and we are going to iterate over the string. I know this is Python and we're iterating over a string. Don't shoot me. So let's see. Let's go for I in range len Roman. Accumulator plus equals convert I. We'll just do a very conventional loop. I could do a for each loop. I'm going to do a counting loop just because I feel like it. I like to type, I guess. And let's go ahead and create that convert function as well. That convert function is going to accept as input a character, say a Roman character, and is going to return the decimal representation of that character. You know what? Actually, that doesn't seem super necessary to me right now. I'm gonna do something else. So let's create a lookup table to perform this conversion. I'm going to use a dictionary where the key is going to be the letter, the Roman character, and then the value is going to be the actual integer. So if I do that, let's call this, what should I call this? I'm not very good at coming up with variable names. We'll just call it lookup for the moment. If I think of a better name, we'll go ahead and use that instead. So we'll go ahead and create our dictionary here. So I am going to map to a 1. B is going to be 5. X is going to 10. L is going to 50. C is going to be 100. E is going to be 500. And M is going to be 1000. So something like that. And then this is going to be nice and convenient because now all I have to do down here is accumulate this. So we're going to go ahead and go in, grab the value associated with our digit and accumulate it. Now, of course, this is only going to work if my input string is actually valid. So if my Roman string is invalid, we're going to get an exception thrown here. We'll deal with that later as well. Again, my goal with this, and this is sort of the methodology that I laid out in that previous video on that, I called it an iterative approach to programming, is that sort of idea. So what we're going to do is we're just going to try and get something working, and then we're going to make iterative improvements upon it until we actually have a solid program that does what we want it to do. So let's see, assuming this actually should work, I think. So we'll just return accumulate that. And I guess we can test it on some really simple cases, huh? So let's see here. Is there anything obviously wrong with it before I run this thing? Parentheses all look matched, brackets all look matched. Don't need a conversion here because it's a string. Yeah, one way to find out. So let's go ahead and run it. And what should our... Let's just try 3. Okay, so that works. Now, of course, what this does mean is that if I give it, right now, if I give it IV, which should go to 4, we're actually going to see 6, because this implementation obviously is not aware of this whole subtraction stuff. We're going to have to deal with that later. But I'm not super worried about that right now. So that works. Oop, if I run program, that gets us 11. So looking good. And if we give it something invalid, like J, we get a, we're gonna get an exception. I forget what kind of exception we get. Key error, that's right. It's been a while since I've worked with Python dictionaries, to be honest with you. So yes, looking good. Let's squelch this key error, I think. May as well do that right now. So as I recall, we have 2 approaches. Obviously, we could be Pythonic about it, and we could do a try it anyway and handle the consequences, right? So if we were doing this in the Pythonic approach, the official Python way, what we would do is we would wrap this in a try except. That's really bad. Never do that. We're going to wrap this in a try except. Always specify exactly what you're trying to catch. Don't just do a blanket accept, because that just makes things worse usually. So we'll accept key error and then print our error message. And then, you know, bad stuff happens. So we would do, what would we do? Let me just actually implement this. Valid input string. We won't be more specific than that. This is just a little demo program. And we'll go ahead and just exit. I believe it's sys.exit. It might be os.exit now that I think about it. Nope, that seems to work. Okay. Yeah, there's obviously in Python, you also have just exit. Right, the Python built-in exit function, which just kills the thing, and in fact, sets your error code. That's 255 -1. Apparently we're using a 8-bit unsigned for that. Doesn't really matter. Of course, you're not really supposed to use Python's built-in exit function like this, because that's actually an extension or a component of the Python interactive shell. And when your Python script is running in script as a script like this and not in the shell, you aren't necessarily guaranteed that that function is actually present. There's ways to run the shell so that it's not. So the way around that is, rather than using Python's exit, we can actually use the system exit. And if I'm not mistaken, this sys.exit is actually what's analogous to, say, the exit function in C that fills the program that way. There you go. Still works. Cool. So this is the Pythonic approach for doing it. Here I am, instead of solving the problem, I'm teaching a figure. This is the Python approach. So in Python, the standard idea is you want to, what's the phrase? It's better to ask forgiveness than seek permission. So just go ahead and, if you have something that might throw an error and break, just go ahead and do the thing. And then if it happens to break, you can handle that case later using a try except. I'm not a huge fan of that. I don't like exception handling. I think it's overused in a lot of cases. So rather than doing that, and I know that Python is basically built on exceptions, for loops terminate because of an exception. There's a stop iteration exception that's used to control loops. That's just the nature of Python. I'm going to go ahead and do this in a slightly more conventional, not Python way, which is to look before you leap. So what that's going to look like is this. I guess we have two real options here. I can either check to see if my key is, or rather if this thing, the Roman I, is a valid key in my array before I do it. And if it is, I do it, and if it's not, I don't. My other option is I could also use the get method. So if I do lookup.get like this, what that's going to do is it will not throw an exception if it's not there. It's just going to assign none. Now, of course, the way this code is structured, that's going to not work, because then I'll end up with a plus equals none situation. So just to demonstrate that, if I run this code with a valid numeral, it should work the same. If I give it, say, j again, we're going to end up with unsupported operand for int and none, because what's happening is when I do this lookup, I get none, which isn't a valid number, and I try and use the plus sign to combine none and my integer, and it doesn't work. So what I'm going to have to do instead is I'm going to have to do something like use an intermediate variable here, decval equals lookup. That if decval, let's see, I could just say if decval, and that should work. I'm going to go ahead and say if decval is none. This is where we do our error case. Invalid input string. Else accumulator plus equals decval. Like that. So now we should work just fine for 3, and J throws the error, and that looks good. So look before you leap. We're going to test to see if the operation will work before we actually do the operation. Some nice defensive programming going on here. You may be asking, why did I do it this way? Excuse me. Where I, if it's none, I do the error handling. Otherwise, I do the actual code. That's just because I don't like negative logic. So we could reverse this if I said if decval is not none, and then do it that way. Or if not decval would probably also work. Let's see. for this, we're looking at an integer, so it would be either none or 0 would be false. Never get 0. So yeah, we could just do this as well. It's not, I don't believe it's considered good practice in Python to do this if your intent is to check for none. But you can do it. So let's see. That works. And then of course, we don't actually need that else. If you want to be explicit, you should put it, but realistically, you don't need it because we're never gonna get there. Now, of course, if I take that else out, well, no, even if I don't take that else out, we're still not a really nice structured program because we have 2 exit points. Whatever. Semantics. Who cares? So there we go. Now we have that fixed and that's working. That's cool. I should probably test it more exhaustively for these things, but it's going to work for any valid combination of these guys. So then the question becomes, how do we handle these guys? And so I think the trick is going to end up being, if we take a look at the layout of all of these, it's like I say here, the smaller digit precedes the larger one. So if you think of these as ordinal, right, you have I, V, X, L, C, D, M. And in a normal, when they're used normally, they're going to be in descending order, right? So I could have M, D, C, L, X, V, I, and if I had that, X, V, I, not C, V, I, and if I had that as my Roman numeral, then all of these are serving in their normal role of being these values here. It's all additive because they're going in descending order, right? You have the biggest one first, and then they get smaller as you go. But if at any point you could do see, is a VX a valid one? No. How about this a valid one? XL is. At any point you have an inversion of that where the smaller one comes first, then in that case, that's a situation where you're going to have to look at subtracting rather than adding. So let's see. There's a couple of different ways you could do this. It's probably not worth using a stack. That would be overkill. We only have to look one ahead. So let's see. We're going to have to wrap this code around this thing here. And it's going to be something like if decval is, yeah. So I'm going to say decval I, the current decimal value, if it's greater than the next one, then that means that we add, and greater than or equal to, rather. And if it is less than, in that case, we're going to need to subtract instead. That's probably going to be the easiest way to do this without having a bunch of special cases, because we could just code a special case for each one of these. But if you think about it, what's really happening here is if you say have, let's say we had xiv, which is going to be 14. What we're doing is this is 0 plus 10 minus 1 plus 5 for 14. So when our digit comes in reverse order, the small one comes first, we want to subtract that one off. And that's going to keep us from having to do a bunch of special cases. We could do a wall of if statements, I think. And just, you know, if I plus the next one is IV, then we do that, and so on. But I think this should work. Now, the only problem we're going to run into here is, again, with our validation. We could get combinations that aren't these, and it would still treat them normally and treat them as valid, right? So, for example, if I had IC, for example, for 99, that's not right. That's not remotely correct. But our code is not going to know the difference. Let's not worry about that yet and just get this working. And then we'll see if we can come up with a better validation strategy. Because I'm thinking one thing we may want to look at doing here is, yeah, because we're going to be parsing entire tokens at a time, not characters at a time. When I say process, what I mean is when we get to reading the data from standard input, we're going to be looking, what gets into this parse Roman function is going to be the whole token. So we actually have the whole Roman digit or whole Roman numeral we're parsing in advance, which means we could pre-validate the whole thing and then sort of separate our validation code from our test or from our parsing code. So we pre-validate it and then we test it. And as long as we're careful with how we structure our code, there's no way we can get to parsing without it being valid, which means we don't have to worry about testing it in here. Let's do that. I like that idea. It's also good for, say, separation of concerns, right? You have the is it okay, and then you have the process it, and you can treat them as two distinct steps. So let's do that. So what that means is I'm going to have to obtain the next value here. So let's say deck value 2 is the next one. That. Now that's only going to work if we are not already at the end. Let's actually do that separately. So deck value 2 is going to be lookup.get Roman I plus 1. Just about did I plus plus. I guess, no, in this case it'd have to be plus plus I for doing it exactly that way. What was I? Ah, right. This is only going to be valid, though, if I is less than the length of our string. I minus 1 is less than the length of our string. Yeah. Then I plus 1 would also be less than the length of your string, and so we're guaranteed that this reference isn't going to fail. Yeah, that'll work. And then that's where we'd have to put let's create a flag. I'm trying to think about how to do this without a whole bunch of duplication of code. And the best bet's probably going to be to use a flag here. So we'll create a flag called decrement. Set that equal to false. So we can do this. And then what we can do is we can say that decrement is equal to decval less than, or decval, yeah, the current decval is less than the next one. So is that correct? So if I had IV, current value is less than the last one, the next one, right? I is less than V, which means this is going to evaluate to true. So decrement is going to take on the value of true. Yeah, that looks good. So then what I can do is if decrement, I can do accumulator minus equals decval, else accumulator plus equals decval. Okay, let's see if that works. So first, let's make sure that it works on a normal one. So we'll go 3 again, I. Oops. I should just install that. Python is Python 3 and save me from all of this. Python 3. Ooh. Failure. All right, what do we got here? So lookup.get Roman I plus 1 out of range. All right, so apparently this if statement did not protect me. Let's see, what had to have happened is we had to be on 2, right? And then 2 plus 1 is 3, which failed. I can't immediately see what's going on here. Ooh. I have to account for that too. I didn't think about that. I can get wonky. Wait a second. So first iteration, second iteration, third iteration. No, wait. That should be a plus, shouldn't it? I think I got that backwards. Yeah, I got that backwards. There we go. And while we're at it, no, that's good. Yeah, because we're never going to get a negative index in there, so that was a non-issue. So 3 gives us 3, and IV gives us 4. Looking good. What's another valid one? Let's see. What if we did CXCIV? So that should be, what, 194? 194. All right, so that's looking good. Now we're looking for time. Not too bad. Okay, so that being the case, let's do the validation next, because this is going to be messy. It doesn't have to be messy, but the way I'm doing it is going to be messy. First off, we can actually get rid of this if statement because we're going to be doing the validation elsewhere. Probably the #1 source of bugs, if you didn't know this already, the #1 source of bugs in a program is when you have multiple if statements checking the same thing in different places. You want to try and keep all of your if statements grouped together. Because what inevitably will wind up happening is if you're checking the same condition in multiple places, if at some point you need to change that condition, well, you'll change it in one place and perhaps forget to change it in all of the other ones, or not even know that it's being changed in all of the other ones. So we'll want to not have duplicative statements, basically. I should really turn off that beeping. Let's see. So let's do def. So before we can parse it, we have to validate Roman. that. And so our code then is going to look like this. And for the moment, let me just dummy this up, return true, make sure our structure works. So if validate Roman. So if it's valid, we parse it. Otherwise, print error, invalid input, and we don't actually even need our we don't actually need that exit anymore. Now I guess we could probably do something like this if we wanted to be particularly kosher about our return codes. If I'm not mistaken, when the Python, no, actually that's not going to work. Right? I'm going to have to use exit. I mean, I could return an error code back out to the global namespace and then return from there, but yeah, I'm going to have to use the easiest way is just to use sys.exit there. Oh. There we go. So that should still work. Oh, wait, Roman string, not Roman. Yep. And we should get 0 there. Sweet. So next step is get this guy working. So the reason why I'm thinking this is going to get messy is because we have a combination of, in the context of parsing the Roman numeral, we have basically a combination of 1-digit long and 2-digit long tokens. So it's not going to be sufficient to just iterate over the string and verify that the only things in it are I, V, X, L, C, D, and M, because they also have to be in a very specific order. And if that order is violated, then we have a problem. So what would be, let me just brute force it with the wall of if statements. It's going to be really ugly, I apologize, and get it working. And then we can take a look at maybe streamlining the checks if we have time. I'm already at 40 minutes and I don't even have a working program. So maybe we'll just leave it the wall of if statements. This is taking a lot more time than I anticipated. I lose all sense of time when I'm doing this, so 60 minutes becomes 5. Yes, so let's stick with having a single exit point for our code. Gonna have to think about that. So for each character in Roman, valid. Let's see. If since I'm using a for loop, if I just use a flag, I have to break. And no, not necessarily. I could say invalid equals false, and then only set it to true when something's invalid. Yeah. And I may end up replacing this for loop with a while loop for efficiency, because it's either that or use a break statement. I have 2 or 3 colleagues who would probably strangle me alive if I chucked a break statement in there. Now, the funny thing about academia is people get very, what's the word? Very particular about their coding style. I suppose you see the same thing in industry. Let's see. I've just completely lost my train of thought. So we're going to be iterating over each character. And what are our options? You know, I'm going to go ahead and make this a while loop immediately, actually, because it's going to allow us a little bit more fine-grained control over the increment. If, for example, what I'm thinking is what I'm going to do is I'm going to first check the letter in my string at this index against this list. And then, say if it's an I, I'll check the next one to see if it's either II, IV, or IX. Will that work? Yeah. Oh, this is going to be a real pain in the ass, isn't it? I suppose I could use... Let's do this. Let's do this. We'll call them single. Because we got what would be good names? Because what I'm going to do. Let me actually say what I'm going to do. Rather than using a wall of if statements, let's use sets. Right? A set is a perfectly. So in Python you have a dictionary and you have a set. A dictionary is a hash table with a key, which is what we have here. Whereas a set is a hash table where the value is the key. And so what I can do is I can create a set of valid single character tokens and a set of valid double character tokens. Yeah. That could work. Or should I use a dictionary? Because I also have to check that they're in the right order. I'm just gonna write. I'm just gonna write code. So while I is less than the length of Roman and not invalid. Tell you what, if I'm gonna be doing it this way, say valid is true. So while there's still string to check and we are valid, we're going to check the string. So what this means, let's call this, I'm going to say single characters. We got I. We got V. We got X. L. C. E. M. Like that. And then we have double. So our valid pairs are IV, IX, XL, C, CD, and CM. And then we're of course going to have that third rule that they have to be in beyond this, they're going to have to be in descending order. So let's first check just the membership in these dictionaries as necessary. And then we can check our word. And we check this if necessary, and then we can check the order later. So if Roman I is in single character, that means that that specific thing is valid. We don't have a J floating around in there, for example. So right away I can say else valid equals false. And then it just becomes a question of what goes in here. So if our thing is a single character, I'm then going to have to check to see if it's an I, an X, or a C. Let me do this. Quick trick. In Python, you can use the test of membership to avoid having a bunch of ors. So rather than if Roman I is equal to or Roman I is equal to X, or Roman I is equal to C, I can just do that. Nice condensed shorthand. So if that's the case, and I plus 1 is less than the length of Roman, then I also have to check to see if this is gonna get ugly real quick. I guess I could take advantage of short circuiting here, right? So if Roman I is in that, and I plus 1 is that, and no, I'm not going to do that. That's going to be a really long if statement. If Roman I plus Roman I plus 1 is in double chair, that means good. Else, again, we'll say valid is equal to false. That's actually not going to work. No, that's not going to work. Because what I really need here is I need to verify whether the next character is larger than or smaller than my current one, right? Because if it's smaller, then I don't do anything special. But if it's larger, then I have to do this. And what that means, I guess, is that I am going to need those values after all. I am going to need to use this lookup table in here too. So let's see. The moment, let me just go ahead and drop that thing into a global namespace. I'm not going to keep it there, but and then the good thing is that if you do a test of membership on a dictionary, that's going to check the keys. So this will work. I can use this lookup dictionary here in exactly the same way as I use this set. The only difference is I now get access to the numeric values for doing a check. Right, so if Roman I is less than Roman I plus 1, yeah, assuming that Roman I plus 1 exists. Of course. So this I should check that first. This, by the way, is where you run into the advantage of the Python approach of just try it and deal with the consequences. Is you don't run into what we're seeing here with the huge amounts of if statements involved in this validation code. So basically, the problem that I have here is we end up in this sort of validation hell, because what I want to do is I want to make sure that the value, and I'm going to have to make these dictionary lookups. Haven't done that yet. I want to make sure that the value of my current letter is less than my other letter, less than the next one in sequence, which is going to then indicate that I should actually go ahead and do these things, right? Because if it's greater, I don't have to do any of that. The problem is that when I go ahead and throw these dictionary lookups on here, this dictionary access is safe. This one's safe because I already checked the condition up here. So we know that this is going to work. However, we also need to check to see if this is going to work too. And in order to check to see if this is going to work, we actually have to check two conditions. We first have to check to see if Roman I+1 exists in my string. We then have to check if the string at, or the character at Roman I+1 exists in my dictionary. So before I can actually even do what I want to do, which is just this really simple dictionary or like integer comparison operation here, I have to actually check two things before I can be sure that this is going to work and not error out. So what I'm thinking is I'm just going to leave that there because I need that anyway. We need to make sure, A, that I+1 is still less than the length of our string. So if I+1 is less than the length of our string, and if Roman I+1 is in lookup, and that. Let's go ahead and do that. All right, so now what we're going to do is we're going to check to see if we're okay, if we're not at the end of our string, and if the next character is valid, and if the current thing is less than the next one, then we do this. Yes. And actually, while we're at it, I'm going to increment I by 1 there. And of course, we need to increment I by 1 at the bottom. I was almost guaranteed to forget that. Yeah. So the advantage of this is now is that right? Or is that going to break things? I'll tell you what, let's not worry about that just yet. And I can play with that later. My thinking was that since we've already, when we're in this situation, when we're here, what this means is we've validated one of these doubles, so IV, XL, or what have you. And so what's going to end up happening then is on the next if we're processing, say, XL, and on this iteration we're looking at X, we've basically just validated both X and L. So on the next iteration, it's going to go to L, but we've already checked L. So if I do an I plus equals 1 here, then that's going to allow us to just skip over that L and move on. But I don't know how that's going to affect. Yeah, because I can't do that because that would potentially break this. or not that. That would break this. When I say it would break that, what I mean is we wouldn't be actually checking that condition on every character. So I could have something like, say I had XL, right? MII. This is invalid because of this M. So I have 1,000 here shoved into the middle of this. So this is basically, this XL is going to be, what would that be, 40? And then I have a 1,000. No good. This check here is going to take care of that. So what this guy is going to do is this is going to make sure that M is bigger or is smaller than L. So because what will happen here is I'm going to say, okay, well, look up, this is L is less than M, which is false. Or I'm sorry, which is true. Which means we get down here and we're going to check to see if we are one of these valid things. And if we're not, then at that point, we invalidate the string, which is what we want to have happen. The problem is that if I skip over this, so if I say process this X, which means we check the whole XL, both these guys get tested because we're in here. If I skip over the L and jump right to M next, then it's going to work. It'll say that it's valid because it hasn't actually checked to see if M is less than L or not, because we've skipped checking L. So I think I'm going to have to leave that in there, even if it means that we're going to be touching things twice on occasion. Actually, I guess we're going to be touching everything twice, aren't we? Let's get it working, and then we'll play around with making it more efficient. I keep saying that. It's very difficult to not fall down these optimization rabbit holes. But what is that? I believe it's Don Knuth, who said that premature optimization is the root of all evil in computer science. We'll get it working, and then we can make it better, make it pretty. So, if our character is valid, then if our character is not the last one, and the next character is valid, and our character is less than the next one, we check to see if it's one of these valid doubles. If it is, we're good. If it's not, we invalidate the string. Otherwise, I suppose we just move on to the next character, right? And that's what's going to happen here. Okay, so let's see if my spaghetti code works. So first off, oh, wait, of course, it's not going to work because I need to, yeah, it would help if I had a return in here. All right, syntax error. Oh, you're kidding me. Line 13. Line 13. End of line continuation. There we go. And that should be look up and not look. There we go. 2, 3, 4, 9. What would be an invalid one? Let's see. CDX 410. Okay. What about IM? Invalid. Well, that's certainly looking promising. So we would want MMMCM. That should be valid. Oh, haha. MMMCM. That should be valid, and it is. And that looks to be correct number as well. Okay. Cool. And yes, I am aware that this particular design is inefficient in many more ways than one. So for example, by completely separating my validation code from my parsing code, what I ensure is that I iterate over my entire string once right here to validate it, and once it's okay, then I iterate over the entire string again to actually parse it. However, the advantage to this technique is by separating it out into these two functions like this, well, it's going to allow me to do two things. It's going to allow me to have independent functions for validating and parsing. So if I ever were to be in a situation where I had a use case where I just needed to validate if the thing was a legitimate Roman numeral or not, but I didn't have to parse it, I have a function for doing that. Plus, merging these together, this is already bordering on obnoxious spaghetti. Merging that into here, it would be pretty bad, I think. So, I mean, it might not. It would just be a matter of replacing some of these valid equals lines. It may be worth to do like a parse valid function that does both of these in one step, maybe. In any case, let's actually deal with this global variable here. How should I do that? Tell you what, I'm going to go ahead and just make this into a module, and then I will just have this be an attribute of the module. So let's call this Roman lookup, and let's also have valid valid single. I'm not going to actually use this valid single thing, but I'll have it for future use. You just want to check to see if a given character is a valid for a Roman numeral. You can use this or the lookup. I mostly just want this valid single because I also definitely want to have a valid double. Or you know what? Actually, let me do this. We'll call this a single lookup, and we'll also just have a double lookup. Because I could see a situation where you wanted to just look up one of these. So IV is 4, IX is 9, XL is 40, XC is 90, CD is 400, and CM is 900. That. Go 2 blank lines there. Get rid of that. That. So first off, I'm going to have to replace every reference to lookup with single lookup. There. And I'm going to want to replace any reference to double char with double lookup. That still work. View. Great. Perfect. No, wrong one. I can never remember that. So SV. Let's go ahead and create a new file called call it Roman R numerals. What the hell am I doing? Go ahead and copy my converter into something called R numerals. But R numerals.py does not need this main code here. We'll just get rid of all this. Might be worth throwing some random test code in there at some point, but rid of that. And then we have my converter, which no longer needs any of this. Import our numerals is going to be that, and we still work. Good. Okay. So next and final step is we're an hour and 10 minutes in. Let's go ahead and actually deal with my standard input stuff. So what I'm going to need to do is I need to read data from standard input. Now, I'll be honest with you, I do not quite remember the best way to check to see if there's actually data on standard input. Does it just return none? File no flush. Probably gonna use read line. Returns empty string if EOF is hit. Okay. This is one of the situations where having a do while loop would be kind of nice, but doesn't seem like that's all right. So go ahead and read line, and then while input data is not none, go ahead and use that negative logic there. Or no, it's not going to be none, it's going to be empty string. So I'm just going to say while input data, because empty string is false. So while we have input data, I'm going to have to get my numerals equals input data dot split on a space. Will that work? Because I also have to split it on a new line, don't I? No, I don't. I'm read line. Yeah, it's space. I guess I probably also should split it on tab, but let's ignore tabs. Separate with spaces, not tabs. So let's see, numerals is equal to that dot split tab, and for I in range numerals, I am going to let's go. Pull that over. Just want to pump that over one more time. And we'll use a for each loop for this. Saves me from typing and renaming code, renaming variables. So for each string in our input strings, we're going to process them. If it works, we print it. If it doesn't, we write to an error message. So I believe I can just do a write. Let's do a write line. Am I looking at standard out? Yeah. Standard out. Well, I guess it's just standard file implementation, so it makes sense it would have read. We're interested in write. Just write the string. So rather than printing, I'm going to say sys.standardout.write. And let's do we'll separate them by new lines. That should work. Otherwise, I want to do sys.standarderror.write error invalid numeral. And since we're doing bulk processing now, it's probably worth being a little bit more explicit about the thing that is causing us problems. Just like that, and we'll just ditch this whole error state stuff. Like that. And we'll just return success. Okay. That was a lot of code changes in one go, so we'll see if any of this works or if I've horribly broken it. So 1, 2, 3. Oh, right. It's not going to accept command line arguments anymore. I want to give 1, 2, 3. Ooh. Have bad stuff happening. Wait. It included the new line. Yeah, it included the new line. So there we go. That worked. Only thing I'm missing, you may have noticed I have a slight infinite loop going on. That's just because at the end of this, I need to make sure that I do this again. And that should deal with that infinite loop. That should be invalid. Yeah. And EOF. Perfect. There we go. Let's go ahead and call that done. Obviously there's a lot more testing that would need to be done to verify that it actually works correctly. I will say that just because of how there we go. Just because of how convoluted the logic of this is, and in the scheme of logic, it's not that convoluted. There is quite a bit of nesting and conditional short circuiting and other stuff going on in there. I would be inclined to think that there's probably at least one bug in that function, and it would require significantly more testing to tease that out, which I'm not going to bore you with here because we're an hour and 16 minutes in by the looks of things. I'll probably take a look at testing this a little bit more, and I might do a follow-on video with that. But anyway, that is a very simple was it RN convert? No. Converter. That's a very simple Roman numeral conversion program. By no means is it efficient. Many ways to improve it, but hey, that's what I came up with on my first pass. So, hope that you found this interesting. You'll have to let me know if this is a format that you enjoy. It's kind of well, I guess the whole point is that it's unprepared, unfiltered, just me figuring crap out. Obviously, we will progress to substantially more challenging problems than this. This was pretty trivial. Makes me think that this is definitely something that's going to require multi-part series or very long videos or something. But anyway, let me know if you like this format, and we'll see about doing some more of it. I like this. This is actually pretty low, what's the word I'm looking for? I don't want to say low effort, but it doesn't require a whole lot of preparation to do. It's convenient. Anyway, found this interesting, and I will see you in the next one.